I will be talking to you about how to identify sex-linked recessive and sex-linked dominant disorders in a pedigree chart. Here you can see the understandings, applications, and skills the IB has given us on this topic. The sex-linked disorders we're expected to be familiar with include red-green colorblindness and hemophilia. We're not expected to be familiar with any dominant sex-linked disorders, as these are both recessive, but you should still be able to see patterns that will tell you if it is a recessive or dominant sex-linked disorder. When a person on a pedigree chart is indicated to be affected by a disease, this means the phenotype, not the genotype, is being discussed. Another thing to understand is that females can be carriers of recessive conditions. What this means is that because they have two X chromosomes, they can have one X chromosome that has the recessive allele and one that has a normal allele, and will then have the normal allele be expressed. This action is referred to as masking. Males are unable to do this as they only have one X chromosome. Some of the main patterns you can look for X-linked conditions is when you have a recessive condition, affected mothers must have affected sons. And then for dominant, affected fathers must have affected daughters. You can see that here. I've taken the liberty to do a little editing on this image. And so now on the left side, our carrier mother is an affected mother, as she has two of the recessive chromosomes. Now you can see that she's only able to donate the recessive allele to her children. Now this doesn't mean anything to her daughters, as the unaffected father will donate a normal X chromosome to his daughters, but the sons, as they receive the Y chromosome from the father, will then be affected as they receive the allele for the recessive disorder from their mother. Here you can see the pattern where an affected father on the right side will pass on the X chromosome for the disease to all of his daughters, but none of his sons, as he only passes on the Y chromosome to them. Here's a chart where you can see the genotype, as they've indicated who is a carrier, and so you can write out all of the chromosomes for each generation. This IB question from 2019 is a way in which you can apply some of this knowledge. The question reads, the pedigree chart shows the inheritance of hemophilia in some of the descendants of Queen Victoria. Which letter points to a family member certain to be heterozygous? We know hemophilia is X-linked recessive, and we also know that males cannot be heterozygous. They cannot be carriers of a recessive disease, so you can immediately rule out B and D. From there on out, you can apply some further knowledge. For C, you cannot definitively say that Helen is heterozygous, but for A, you can definitively say that she is heterozygous, as both parents are unaffected and they have an affected child, but we do know that also the father cannot be a carrier. So the correct answer here is A. You can now take the knowledge you've learned to answer this question, and I will read you the answer after you solve. You can pause now. The answer is A. Thank you all for listening, and I hope you have a wonderful day.